Continuing on with number 3 here. Calculate the molar solubility of magnesium fluoride in 0.1 molar magnesium chloride at 25 degrees Celsius. All right. So we look up, magnesium fluoride has a KSP of 5.6 times 10 to the negative 11th. Magnesium chloride has no KSP, and it is soluble. All right? And we can assume it's soluble because it gives you a concentration of 0.1 molar. All right? And so if we look at this, we have magnesium chloride, which magnesium is Mg2+, right? And then chloride is Cl-, fluoride is F-. So magnesium chloride, MgCl2, solid. This is 100% going to Mg 2+. And 2 Cl-. And we have, what, 0.10 molar. So we have 0.10 molar and 0.20 molar. Excellent. Well, magnesium fluoride we got magnesium and 2 F-. All right. So if you notice something right here, this we have a common ion. And if you remember, common ions suppress the ionization of the weak electrolyte. So if we were to do our ice table here, we would have some magnesium fluoride. Initially, we'd have 0.1 and 0. Then we'd have plus X and 2X. So here we have 0.10 plus X and 2X. So that's what we have, all right? So we write our KXP expression. KSP is equal to magnesium 2+ times F- squared. All right, so KSP was 5.6 times 10 to the negative 11th equals, we have 0.10 plus X and X squared, or 2X squared, excuse me. All right, now, because this is 0.1, 10 to the negative 1, 10 to the negative 11. It's 10 to the 10th times difference. We can approximate this X to 0, right? I'll actually write that. So this becomes 5.6 times 10 to the negative 11th equals 0.10 times 2X squared. All right. So this is how we attack a common ion, a problem with a common ion in it with the solubility product. Right? The addition's not going to change. So now to solve this, you have your 5.6 times 10 to the negative 11th, and you're going to have to divide by 0.1. All right, which makes that 5.6. 5.6 times 10 to the negative 10th equals our 2x squared. Now this, again, take your time here. 5.6 times 10 to the negative 11th equals, this becomes 4x squared. So then we divide by, I saw I just carried it over. That's a 0. Divide both sides by 4, and we get 1.4 times 10 to the negative 10th equals x squared. So x, which equals the concentrations of magnesium fluoride, is 1.2 times 10 to the negative 5. All right. And so if we look at the question, that's what we want. We want x. All right. Fluoride, concentration of fluoride, if it were to ask you that, would be 2.4 times 10 to the negative 5 molar. All right. And magnesium would be the 0.1. All right. So that's how we do that example with the common ion. It doesn't matter if it's the cation or the anion, but that's how we take care of it. All right. Next topic that we need to talk about is the reaction quotient or solubility quotient, QSP. Right? And of course, QSP is the value of the product of the ion concentrations. All right, so now we have ifs and then we have then. So if QSP, there's going to be 3 of them. Now we're comparing them to KSP. So if QSP is bigger than K, all right? Well, that's been, if Q is bigger than K, there's been too many products and not enough reactants. It's a left shift. It's a shift to reactants, right? That's what it used to be. But now what we say is concentrate, then, right? It's still too many products, but then concentrations of products are too high. We say precipitation will occur. All right, so we make it precipitate. It's still a shift to the left. We can even write that there, but it's going to precipitate, all right, because it's a solubility product. If the opposite is true, if Q is less than K, right, the solution is unsaturated. It's unsaturated and more solid can dissolve. Now, that doesn't necessarily mean it's going to be a right shift, though, right? Okay, what do I mean by that? Well, if you only put so many, let's say, milligrams of your compound in and it all dissolves, there's nothing to shift. You can just add some more of your compound. All right? And of course, if we are equal, right, the system is at equilibrium. And the solution is saturated. All right, so those are the three options when we do a Q and we do a K. All right. And so it doesn't matter what this is. So we talk about this. If I have MX solid and we go M plus X minus QSP is equal to M plus X minus, right? So no matter what we have, that's what's going on. It's the same as K. It's the same expression. It's not necessarily at equilibrium, but it could be. All right, let's do an example. Suppose you have 50 milliliters of 5 times 10 negative 4 molar silver. It's added to 50 milliliters of 4 times 10 negative 3 molar chromate. The question is, will precipitation occur? And it gives you KSP for silver chromate. And so we have silver, 50 milliliters of that solution. And we have 50 milliliters of that solution. All right, so what do we have? Little picture here. If I have a beaker and a beaker and then a bigger beaker. All right, so we have 50 milliliters, 5.0 times 10 negative 4 molar, and this is for Ag plus. So maybe it's AgNO3. It could be nitrate. Most likely it's something soluble. Typically, that's going to be silver nitrate. And we're going to put that into here. And then we have 50 milliliters, 4.0 times 10 to negative third molar, and that's going to be chromate. Could it be Na2CrO4? Possibly, but we don't really know, nor do we care about that and that. We don't care about those, right? Because they're not going to do any extra chemistry. And this is going in here. So this means that now we're going to have 100 milliliters. And because we're going to have 100 milliliters, we're going to do the dilution, right? So what happens to the volume? If you remember this, M1V1 equals M2V2, right? If the volume goes from 50 to 100, that's like going from 1 to 2, right? So if the volume goes from 1 to 2, that means our concentrations are going to go from 2 to 1, right? That makes sense? It's going to half. We get a half. If the volume doubles, you half the concentration. So this becomes, half of 5 is 2.5. So for silver ion, this becomes 2.5 times 10 to negative 4 molar. And for chromate, this becomes 2.0 times 10 to negative third molar. All right. And just to do, we'll do the silver one for us. M1V1 equals M2V2. So we have 5.0 times 10 to negative 4 molar, 50 milliliters, M2 times 100 milliliters, right? And so if you look, M2, do that math, you'll get 2.5 times 10 to negative 4 molar. Same thing happens with chromate here, right? M1V1 equals M2V2, right? And so you would have 4.0 times 10 to negative third molar, 50 milliliters, M2, 100 milliliters. And so M2 is 2.0 times 10 to negative third molar. All right. Now, what is the reaction? Silver chromate. All right. So we got to have Ag2CrO4 solid 2 silver ions and chromate. So QSP would be equal to silver ion squared times chromate. Well, we know what those are. So QSP, all right, for silver, it's 2.5 times 10 to the minus 4 molar. Chromate, 2.0 times 10 to the negative third molar. So it looks like our QSP would be what? 2.5 times 10 to the negative 4. And we're going to square that times our 2.0 times 10 to the negative third. I get 1.25, so 1.3 times 10 to the negative 10. Well, K is 1.12 times 10 to the negative 12. So that means Q is bigger by a factor of 100. So this means precipitation occurs. Right. I think that's it. So there's Q. If you have any questions, feel free to reach out. Otherwise, we'll see you next time, guys. Take care.